Most people assume that truly waterproof, lightweight, and durable fabrics are a post-war invention, something that only became possible once plastics, synthetics, and petroleum chemistry matured. But, that assumption is wrong. During the Second World War, long before Gore-Tex or modern laminates, militaries quietly fielded a fabric that outperformed canvas tarps, oilskins, and rubberized cloth in critical survival situations. It was lighter than most field shelters, breathable enough to prevent hypothermia, and when wet, it sealed itself tighter rather than failing. It was not widely advertised, not cheap, and not intended for mass issue. It was designed for men who had only minutes to survive after everything else had already gone wrong. This fabric did not change the course of any famous battle, but it quietly shaped survival outcomes, post-war textile science, and even modern preparedness thinking. And, honestly, because it worked too well, it was largely forgotten once the war ended. This story begins not in a factory but in cold water. The problem that forced militaries to rethink fabric came from the air and the sea. This story begins not in a factory but in cold water. The problem that forced militaries to rethink fabric came from the air and the sea. By the early years of World War II, the Royal Air Force was losing aircrews at an alarming rate, not just to enemy action, but to exposure as well. Bomber command crews shot down over the North Sea or the English Channel often survived the initial impact, only to die of hypothermia within minutes. Existing flight gear relied heavily on rubberized fabrics and oil-treated canvas. These materials were technically waterproof, but they trapped sweat, stiffened in cold conditions, and, failed catastrophically once creased or damaged. Worse still, rubberized layers lost flexibility at low temperatures, causing seams to crack and water to rush in. Survival analysis conducted by British medical and aviation authorities revealed a critical insight. Water resistance alone was simply not enough. The body needed insulation, breathability, and a fabric that did not rely on coatings that degraded under stress. If a pilot could stay dry without sealing in moisture, survival time in cold water increased dramatically. This, forced a rethinking of what waterproof actually meant. British textile engineers turned to cotton and did something, counterintuitive. Instead of abandoning natural fibers, British researchers focused on refining them. The result was a tightly woven, long-staple cotton fabric that relied on fiber density rather than surface coatings to stop water. When dry, the fabric was breathable and flexible. When wet, the cotton fibers swelled, closing microscopic gaps in the weave and forming a natural water barrier. This material became known as Ventil. Unlike waxed cotton or oilcloth, Ventil had no applied waterproof layer to crack, peel, or stiffen. Its performance actually improved when soaked. Rain, spray, and even immersion caused the weave to tighten rather than fail. At the same time, moisture vapor from inside could still escape, reducing condensation and heat loss. The fabric was also remarkably strong for its weight. A single layer could withstand significant abrasion, wind, and tearing, outperforming heavier canvas tarps used for ground shelters. Ventil was not cheap. It required high-quality Egyptian cotton, precision weaving, and careful finishing. That cost limited its use, but for RAF aircrews, cost was secondary to survival. This fabric was issued not as comfort gear, but as life insurance. Ventil was primarily used in immersion suits, flight jackets, and cold-weather smocks for pilots operating over water. Its role was not to keep someone comfortable for days, but to keep them alive long enough to be rescued. Tests showed that aircrew wearing Ventil-based garments could survive significantly longer in near-freezing water compared to those wearing rubberized gear. What mattered was not absolute waterproofing, but the balance between water resistance, breathability, and thermal retention. Ventile garments absorbed some water, but they prevented the rapid flushing that stripped heat from the body. At the same time, trapped air within the fabric structure added insulation. This approach represented a fundamental shift. Instead of treating water as the only enemy, designers treated heat loss as the true killer. That insight would echo quietly through later military and outdoor equipment design. On the ground, similar lessons were being learned under different conditions. In contrast, tightly woven cotton shelters, when properly tensioned and allowed to swell with moisture, shed rain effectively while remaining breathable. Scandinavian and British troops operating in cold, wet climates found that dense cotton fabrics reduced internal condensation compared to impermeable materials. This mattered for morale, health, and readiness. The lesson was subtle but important. A shelter that breathes slightly but manages moisture can outperform a fully sealed one in prolonged wet conditions. This principle remains central to modern cold-weather survival doctrine. The material worked so well that it exposed the limits of industrial thinking. Despite its effectiveness, Ventile and similar fabrics did not become universal military standards. The reasons were logistical and economic rather than tactical. Long staple cotton supplies were limited. Production was slow. Synthetic materials promised scalability, uniformity, and lower cost. After the war, nylon PVC coatings and later polyurethane laminates dominated military procurement. These materials were lighter on paper, cheaper per yard, and easier to mass produce. In controlled conditions, they worked well. In prolonged field use, especially cold and wet environments, they introduced new failure modes: delamination, brittleness, and condensation issues. Ventile, quietly found its place in niche roles: polar expeditions, special forces garments, and even civilian outdoor clothing, for those who really understood its trade-offs. It was never well marketed aggressively. It didn't quite fit into the post-war narratives of technological progress, and as a result, most people simply forgot it existed. The survival lessons embedded in this fabric, they still matter today, don't they? For modern preparedness-minded individuals, the history of Ventile, it challenges several assumptions. Waterproof, well, it does not mean impermeable. Lightweight, does not mean fragile. And high-tech, it does not always outperform refined low-tech solutions. Tarps made from modern plastics excel at certain tasks, but they can fail silently through UV degradation, pinhole leaks, or catastrophic tearing in wind. Breathable natural fabrics behave differently. They age more predictably, fail gradually, and can often be repaired in the field. It's quite fascinating, really. More importantly, they force the user to think in systems. Shelter, clothing, insulation, and ventilation must work together. WWII engineers learned this under extreme pressure, with lives depending on subtle material behavior rather than marketing claims. Those lessons were paid for in cold water and long nights. Remembering overlooked technologies helps us understand how progress actually happens. Ventile was not a miracle fabric. It had drawbacks. It was heavy when fully saturated. It dried slowly. It required maintenance. But, it worked because it was designed around real human limits, not idealized conditions. World War II accelerated innovation, but it also revealed how often simple, well-understood materials outperform complex systems when failure is just not an option. The men who depended on this fabric rarely knew its name. They only knew that it bought them time. That is the kind of history worth preserving, not because it is dramatic, but because, honestly, it is honest. If you value serious, in-depth historical analysis that looks beyond surface narratives and focuses on what actually mattered, consider subscribing to Old World Prep. And if this story added something to your understanding of warfare, survival, and preparedness, share the video with someone who takes those subjects seriously.